Good morning, all. It's a beautiful late morning here in sunny California. This is Henry from ASTEM Tutoring, once again attempting to serve as your wise old sensei. Today, I'd like to continue our discussion of center of mass, in particular, finding the center of mass of a continuously distributed mass. So something where we need to use integrals to find. So let's head over to our whiteboard. Suppose we have a solid that was formed by taking the function f of x equals e to the negative x and rotating it about the x-axis, and we take it from the limits from x is 0 to x is positive 4. Kind of looks like a cylinder turned sideways with the base flared out. So to find the center of mass of this object, we can use the formula discussed previously. X of the center of mass equals 1 over capital M, the total mass of the object, times the integral of x dm, where dm is a differential piece of the mass of the object. So to find the total mass, assume the density of the object is a constant 1, then the total mass is merely the volume of the object, and to find that, we could do m equals the integral from 0 to 4 of pi r squared, where r is f of x. So we'd have pi times e to the negative 2x dx. If you recall from calculus and integration, that would turn out to be pi over negative 2 times e to the negative 2x, with the limits taken from 0 to positive 4. And that would be the mass of the total object. Now, to find the integral part of xcm, the integral of x dm equals x times pi e to the negative 2x dx. This does not lend itself to a simple one-step integration. Instead, we can use integration by parts to solve this integral, and then we multiply the result times 1 over m, which was calculated in the first step of today's lesson. In the interest of keeping today's lesson short, we will save the integration by parts solution of this for tomorrow's lesson. So stay tuned, and tomorrow I'll demonstrate how to use integration by parts to solve this integral, and we will put it all together to find the center of mass of this fictitious object. This concludes today's lesson. We've started discussing how to find the center of mass of a continuously distributed mass. If you'd like to learn more, I'm available for hire as a private tutor. The first 1-hour lesson is free for all new students. Try before you buy. You take no financial risk. The burden of proof is entirely on me to demonstrate outstanding service in helping you succeed. You can see my contact information in red at the center top of the whiteboard. And as a thank you for watching to the end of today's lesson, when you contact me, please mention the code FREEBOOK. And when you do that, at our first lesson, I will give you a free copy of my book, Smart Suggestions for Student Success. This book is also available for purchase on the Barnes & Noble website. I wrote this in an attempt to help students, and particularly high school students and college students, to succeed in school, work, and in life. Thanks for watching. Have a good day.